Good day, grade 10 students, Section John, and welcome to Science 10 first quarter module and video tutorial for week number 2. And before we proceed with the discussion proper, gusto ko muna kayong kamustahin. Kamusta naman kayo, grade 10? Kamusta naman yung 2 weeks na nating pag-online class? For sure, lahat kayo ay challenge, tama ba? At the same time, nasa-challenge pa rin kayo, nag-a-adjust, nag-a-adapt. Pero don't worry, lahat naman tayo ay nandyan sa ganyang proseso. Pero we need to know that we need to continue and we must continue kasi meron tayong objective na gusto nating matuto kahit na nasa ganito tayong sitwasyon ngayon. And speaking of objectives, this module and video tutorial number 2 has its own lesson objectives. And let's have the lesson objectives for this video tutorial number 2. So at the end of the lesson, you are expected to first is to familiarize with the nature, types, and importance of seismic waves and to know the different forces that influence the plate movements. And before we have the lesson proper, let us have first the preliminary activity. So this is activity number 1, what's on your mind, and for the directions, you are going to answer the question below by writing your answer on the space provided after each question. So this is just to test your prior knowledge regarding our lesson to be tackled. So number 1 is, how did the scientists able to map the inner Earth? Second is, what is your idea about seismic waves? And third, what are the differences between seismograph, seismogram, and seismometer? So you can pause this video for a moment and answer activity number 1, what's on your mind. And if you're done answering activity number 1, you can proceed with the lesson proper. So let us have now lesson proper, and for the lesson proper, let us have first the lesson 1.2, mapping the inner Earth. And for this lesson, we're going to have 2 questions first. And what are these? Number 1 is, how did the scientists able to map the inner Earth? So, paano ba nila nalaman yung inner Earth? And also, how did they identify the thickness and the natures of each layer? Well, the answer lies here. So, they studied thousands of earthquakes and they learned more about the inner Earth. And they examined what we call waves of energy called seismic waves. And these waves of energy travel through the planet when an earthquake occurs, when block of rocks break, when volcano erupts, or when tectonic plates move. So basically, if there are occurrences like earthquake, moving of blocks or breaking of blocks of rocks, and also whenever there is eruption of a certain volcano or any tectonic plates movements, there is what we call releasing of these waves of energy called the seismic waves. And these seismic waves became the tool and the way in order for the scientists to map the inner Earth and to identify the thickness and the natures of each layers. In understanding the nature of the seismic waves and its importance, we need to have our knowledge with regards to the following. So what do you think is that picture all about? How about this? So actually, these are equipments, instruments that we use in detecting, recording, and analyzing of seismic waves. And there is a question. So what do you think is that picture? Is this a seismometer or a seismograph? Any guess? So if your answer is seismograph, then you're correct. So that picture is an example of seismograph, wherein seismograph is the one that records the detected seismic wave. And the question is, what is the seismometer? So seismometer, on the other hand, is a highly sensitive instrument that detects the seismic waves. So this seismograph and seismometer works hand in hand, because this seismometer is actually located inside the seismograph, wherein the seismometer is the one who will detect the seismic wave, and after this detection, it will be then recorded by the seismograph. And how about the next picture? So that is the seismogram. So after siyang ma-record ni seismograph. So what we will have now is the seismogram, wherein this is the recorded data of the seismic wave. And this is the data where it will be the basis for the identifying of the magnitude and other stuffs about earthquakes. And just a recap, so we have here the seismogram, and we have the seismograph, and inside the seismograph we have the seismometer. Seismometer is a highly sensitive instrument that detects the seismic waves, wherein on the other hand, the seismograph is the one that records, and then after niyang ma-record yun, magkakaroon tayo ng seismogram. And let us have now the types of seismic waves. Actually, there are two types of seismic waves that are released during an earthquake. And as you can see in figure 1-5 on your screen, this shows the paths of seismic waves through the Earth's interior. And we are going to discuss the two major types of seismic waves. And let's proceed with the first type, which is the body waves. So body waves is the type of seismic waves that travel through the inner layers of the Earth. So take note, travel through the inner layers of the Earth. And during an earthquake, two types of body waves radiate in all directions, and these are as follows. But take note, body waves, tumatago siya, okay, nagta-travel siya through the inner layers of the Earth. And then meron daw tayong dalawang type of body waves na nag-radiate in all directions during an earthquake. And these are, first, the primary waves. So as you can see in this GIF, okay, so we have the direction of the propagation and how this primary wave or the P wave behaves. And it is actually the faster seismic waves that is first to be felt on the Earth's surface. So take note, primary, kaya siya primary kasi siya yung una. And this is also the faster seismic waves. Now again, siya yung unang mararamdaman sa Earth's surface. And moreover, it is also a longitudinal or compressive wave that shakes the ground back and forth in the same and opposite direction through which they move. And as you can see here in the GIF, so pinapakita natin dyan kung paano nangyayari yung longitudinal and compressive wave na nakakaroon ng bouncing back and going back of the ground back and forth in the same and opposite direction kung saan papunta yung seismic waves. So that's the primary wave, and it also travels through both solid rocks and fluids at the speed of 1.5 kilometers and 8 kilometers per second. So take note, primary waves, both solid rocks and fluids. So basically, nag-travel siya in all the layers of the Earth. That's the primary waves. And let's have the second type of body wave, which is the secondary waves. So secondary waves is also called as S-wave, wherein it is also called as a transverse waves, which are felt in an up and down motion perpendicular to the direction of the wave. And as you can see in this GIF, so it shows how these transverse waves are being felt in an up and down motion perpendicular to the direction of the propagation. So next is, if you're going to compare this wave, this secondary wave with the primary wave, this wave can only move or travel through solid rock compared to the primary wave, which it can travel both dun sa fluid and solid. Well, this time, itong secondary waves sa solid rock lang siya makaka-travel. And recap tayo of the two types of body waves. So we have the primary waves and the S waves. And here, this GIF shows the different movement of these two types of body waves. Next, let's have the second type of seismic wave, which is the surface wave. So as this name implies, so these are seismic waves that travel only through the Earth's surface. Kaya nga siya sinasabing surface waves. And also, it do not penetrate to the inner layers, and they move slowly than the body waves. But although kahit nag-move siya slowly, surface wave is much more destructive than the body waves. And these are felt towards the end of an earthquake and are responsible for greater damage. So as I've mentioned, although slowly siya na nagmo-move pero still responsible to for a greater damage. And we have two types also. The first one is the love waves. Okay, and you can see on the GIF kung paano nag-occur si love wave. And love wave is named after the British geophysicist and mathematician Augustus Edward H. Love, who worked on mathematical models to demonstrate the propagation of surface waves and the structure of the Earth. And also, these love waves are the fastest waves of the surface waves and move the ground from side to side. So makita nyo rin dun sa propagation of direction of these love waves na talagang minumove niya yung ground from side to side. And take note of this. One fact about these love waves is that this is the most destructive wave. And the second type of surface wave is the Rayleigh waves. So Rayleigh waves is named after John William Strutt, also known as Lord Rayleigh, whose mathematical modeling predicted the possibility of this type of waves. And the nature of this wave is that, okay, it moves in a circular manner, similar to the rolling of the ground, and cause buildings to heave up and down and side to side. And if you're going to take a look with the GIF, you can see how these Rayleigh waves can cause the buildings to heave up and down and side to side. So it's really dangerous. But love wave is much more dangerous than these Rayleigh waves. And here we have the two types of seismic waves, the love and the Rayleigh waves, showing the different propagation of their movements. Alright. And let's have the summary of the seismic waves. So under the body waves, we have the P and the S waves, and under the surface waves, we have the love and the Rayleigh waves. So next, we have lesson 1.3, mechanisms of plate movement. So at this time, we're going to have our knowledge regarding the question, how do plate moves? Okay, paano ba sila gumagalaw? And that is because of the following forces. So here we can see the different forces that drives and resists the movements. And there are actually two major types of forces. And what are these? So let's have the first one. Kindly guess the first one. So what can you see on that GIF? So that is actually a man driving. And our first type of force that helps in the mechanisms of tectonic plates is the driving force. And the second type we have, how can you say no? So what's your idea about this? Okay, so take note, every time that you're going to say no, you're actually resisting. So that's why the second type of force is the resisting force. And let's have first the driving force. So driving force are forces that either push tectonic plates toward each other or pull them apart. So this driving force has something to do with the convergent plate boundaries interaction and the divergent plate boundaries interaction, wherein we're going to tackle it on our next video tutorial. And also, there are different kinds of this force that push or pull the tectonic plates, and these are as follows. Actually, there are four. Let's have the first one, which is the mantle convection. So you can see here the mantle convection. Here we have the mantle convection, and mantle convection is somewhat related to the convection current that happens in the mantle. Okay, and it is heat in the core rises toward the mantle, increasing its kinetic energy and causing it to expand and spread out beneath the plates. and this drives the plates away from each other. So this mantle convection is the reason why two plates are moving away from each other. Next, driving force, we have the slab pull. So this is the slab pull. Here we have the slab pull, and this is actually it takes place when a subducting slab sinks into the hot mantle because of a different temperature. Because of the sudden change in temperature, what will happen? Makakaroon ng subduction zone, and this causes the rest of the plate to which the slab is attached to be pulled in as well. So that is the slab pull. So ito siya, nakikita natin dyan sa screen, yung pababa na kulay red. So this is the slab. Next, we have the slab suction. So slab suction, on the other hand, is the one that is in the circular motion. So it occurs between the two colliding plates, one of which is subducting underneath the other plate, whereby convection currents in the upper mantle suck both plates down. So ito, pababa nga, di ba, nagkaroon ng separation or moving away of two tectonic plates, and this slab suction will occur. Okay, so magkakaroon dito ng slab suction wherein yung two colliding plates ay magkakaroon ng additional force or makikreate ng force na tinatawag natin na slab suction. Next is the ridge push. So ridge push is located here. So it happens when the lithosphere is pushed up by the asthenosphere because of the convection current from the mantle, and that is also because of the gravity. So the gravity pushes the plate down the ridge and a new crust is formed. So here we can see, okay, we can see here that there is this new crust that is being formed because of the gravity, and that is also through the help of this ridge push. So we're done with the driving forces, and now let's have the resisting force. So resisting force are forces that act against the driving force of plate tectonics. They include the following. Number one, we have the slab resistance. So slab resistance, yan ay mga kulay black ang mga resisting force. So slab resistance is concerned when plates collide at a plate boundary in a subduction zone, the force will resist movement. So ito siya. Si slab, ito. So slab resistance is the one who will resist the movement. Okay, pag nagkaroon ng subduction zone. So next is the collisional resistance. The collisional resistance is occurring when heavy plate is pulled into the mantle but resists subduction because of friction. And this force opposes the what we call slab pull. So sa slab pull, pababa sa kanina, di ba? Because of the formation of the subduction zone. Pero here, we have the collisional resistance na magre-resist na mag-form ng subduction zone because there is this what we call friction. Third, we have the transform fault resistance. So sometimes the spreading of the center along the ridge is broken by several kilometers. When this happens, the broken slide past each other and form a transform fault. So take note, nakakaroon ng formation ng transform fault. And transform fault is one of the type of fault na nafo-form sa boundaries interaction wherein nafo-form siya dahil naggigit-gitan or kiskisan yung dalawang plate tectonics. And since the movement is opposite, the plates encounter frictional resistance in the contract zone. And we have the last resisting force, which is the drag force. And this resists movement in the lithospheric plate. So ito siya. Dito siya sa may lithospheric plate. So kasi mag-move tong plate na to, di ba? Pababa, tapos magkaroon din dito ng sudden movement pababa, and syempre mag-move yan, and there is this drag force na magre-resist dito sa part na to. And this time, it is your turn. So what do I mean? It is your turn because you are tasked now to answer the following. First is activity number 3, fill me out. Activity number 4, modify true or false. Activity 5, complete me. Activity 6, I wanna know you. And activity 7, wave me like you do. So for the specified instructions, so kindly read the directions under each activities. If you have questions or clarifications regarding our lesson or anything Okay, so don't hesitate to contact me, FB account RJ Solis Olarve, Gmail, we have disciplerj@gmail.com, and cell phone number 0975-705-1548. And just a reminder from 1 Corinthians 10:31, when you eat or drink or do anything else, always do it to honor God. So sa pagkasagot nyo nung lahat ng mga activities natin sa science and other modules nyo, so always keep in mind that you are actually doing it to honor God. So that would be all. See you on our meetup via Zoom. So this is again Director RJS Olarve. God bless grade 10.